What are peptides? Good day, everyone. Peptides are having a moment. You hear about them at the gym, in skincare ads, on social media, and in conversations about weight loss. Some people say peptides can help you sleep better, recover faster, build muscle, improve your memory, heal injuries, and even slow aging. That is an impressive list. It is also where confusion begins. The word peptide covers many different things. Some peptides are well known medicines that have saved lives for generations. Others are still being studied. A third group is being sold online with claims that are far ahead of the science. Today, my goal is simple. I want you to understand what peptides are, why people are excited about them, and how to tell real medicine from clever marketing. What is a peptide? Let me put that in plain English. Your body is built from proteins, and proteins are made from smaller pieces called amino acids. Think of amino acids as letters. A short group of letters makes a word. That is like a peptide. A long group of words makes a sentence. That is more like a protein. Peptides are short chains of amino acids that carry messages throughout the body. They tell cells when to start something, stop something, speed something up, or slow something down. Some help control blood sugar, some affect blood pressure, some influence pain, mood, sleep, healing, growth, or reproduction. Your body already makes thousands of peptides. Insulin is a peptide. Oxytocin is a peptide. Endorphins are peptides. Vasopressin is a peptide. Scientists have studied peptides for more than 100 years. Insulin, one of the oldest peptide treatments, has saved millions of lives. So peptides are not strange new substances invented by internet wellness clinics. But the word peptide does not guarantee that something is safe or effective. Tell me what you took from that. A peptide can be a proven medicine. It can also be an untested chemical sold in a vial. The name alone tells us very little. Why is everyone talking about peptides now? Much of the excitement comes from diabetes and weight loss medicines such as semaglutide and tirzepatide. These belong to a group known as GLP-1 medicines. They help control blood sugar, reduce appetite, and support weight loss in appropriate patients. Their success has made people wonder whether other peptides might also have powerful medical uses. That curiosity is reasonable. The problem begins when people place every peptide into the same basket. Imagine walking into a store where one shelf contains insulin and another contains an experimental powder labeled research use only. Both may be called peptides, but they do not belong in the same category. One has years of human research, clear dosing instructions, and medical oversight. The other may have a few animal studies, online testimonials, and a seller who never meets the buyer. That difference matters. Some online communities also promote peptide stacks. A stack means combining two or more peptides. The idea is that the products may work better together. That may sound logical, but mixing two poorly studied substances does not create better evidence. It creates more uncertainty. A person may say, "This cured my shoulder pain," or "This helped me sleep better." That experience may be real for that person. Still, one story cannot tell us whether the product caused the improvement, whether the person would have improved anyway, or whether the same product might harm someone else. Personal stories can start a scientific question. They cannot finish it. Compounded does not mean FDA-approved. Some peptides may become available through compounding pharmacies or telehealth clinics. This can make them appear more official, but access and approval are not the same thing. In July 2026, an FDA advisory group supported allowing certain peptides to be compounded in specific situations. These included BPC 157, KPV, MOTS-c, TB 500, epitalon, and semax. A clinician may be able to prescribe a compounded product for a specific condition. That does not mean the FDA has approved the product as safe and effective. An FDA-approved medicine goes through a formal review. Researchers study how it works, what dose should be used, what side effects may occur, and how the product must be manufactured. A compounded medicine does not go through that same complete approval process. Here is what I want you to remember. A prescription may make a product legal to provide in a certain setting. It does not erase the gaps in research. Peptides and weight loss. Weight loss is one of the biggest reasons people seek peptide treatment. For patients who qualify, established GLP-1 medicines are the best known peptide-based options. They have human research, approved uses, and dosing guidance. The concern is with products sold under labels such as research use only, for experimental use, not for human use. Those labels should stop you. They may mean the product was made for laboratory testing rather than for injection into a person. With an unregulated vial, you may not know whether the label is accurate, whether the dose is correct, or whether the product is contaminated. One peptide discussed for weight loss is MOTS-c. MOTS-c comes from mitochondria, the parts of our cells that help make energy. Early studies in cells and animals suggest it may affect metabolism, blood sugar, weight, and bone growth. That sounds promising, but promising is not the same as proven. There is not enough human research to show whether MOTS-c works for weight loss or whether it is safe over time. Imagine this. In a laboratory, researchers give a mouse a carefully measured dose. They control its food, environment, and activity. They watch it closely and record every change. Now compare that with a person ordering powder online, mixing it at home, and choosing a dose from a message board. Those situations are not remotely equal. Approved weight loss medicines also require medical guidance. They can cause nausea, constipation, tiredness, and other side effects. A clinician can adjust the dose, manage symptoms, and determine whether treatment should continue. Weight loss care is not simply a weekly injection. It includes nutrition, activity, monitoring, realistic goals, and follow-up. Peptides in skincare. Skincare companies love peptides because the word sounds advanced. You may see products advertised as helping with wrinkles, firmness, healing, or collagen production. Some are even called Botox in a bottle. That phrase deserves a closer look. Botox works beneath the skin. It blocks a message traveling from a nerve to a muscle, which reduces muscle movement. A cream sits on the skin surface. For that cream to act like Botox, it would need to pass through the skin, reach the correct nerve, and affect the muscle below. The skin is specifically designed to prevent substances from passing through easily. That is its job. Peptides can also be unstable. Heat, light, air, or storage conditions may cause them to break down before they ever reach the skin. Here's why this matters to you. A product can contain a real peptide and still fail to deliver a meaningful amount to the place where it needs to work. That said, peptide skin products may have a role in certain situations. Treatments such as microneedling and laser resurfacing create tiny openings in the skin. After these procedures, selected ingredients may enter more easily and support healing. Copper peptides and certain tripeptides may be useful in that setting. Palmitoyl tripeptide 5 is one example that has been discussed for healing. KPV is another peptide marketed for wound healing, inflammation, and immune support. Some sellers also claim it may help bowel disease, Lyme disease, or problems blamed on mold exposure. Those are wide-reaching claims. Human evidence is still limited. One study using human skin from cadavers found that KPV did not pass through the skin barrier well, which may limit the value of a cream. For most people, good skin care should begin with proven basics: sunscreen, a gentle cleanser, a moisturizer, tretinoin when appropriate, antioxidants when appropriate. A peptide cream may be an extra. It should not replace the foundation. Peptides for sleep and brain health. Peptides are also being promoted for sleep, headaches, focus, memory, and neurological conditions. 3 commonly discussed examples are epitalon, epitalon, and semax. Epitalon is connected to the pineal gland, which helps regulate melatonin and the sleep-wake cycle. One small human study suggested that epitalon might increase melatonin. It is also promoted as a longevity treatment. The longevity claim often focuses on telomeres. Telomeres are protective caps at the ends of chromosomes. Think of the plastic tips on shoelaces. They help protect genetic material from damage. Short telomeres are associated with aging and disease. That has led some people to assume that longer telomeres must always be healthier. The body is not that simple. Very long telomeres have also been linked with certain cancers and with a blood condition called CHIP, which can increase the risk of blood cancers and heart disease. Changing the way cells age may also change the way abnormal cells survive and grow. An anti-aging claim can hide a serious biological trade-off. Emideltide. Emideltide is a peptide made in the brain. It has been studied for deep sleep, also known as stage 3 or slow wave sleep. Animal studies have shown an effect on deep sleep. Small human studies were performed as far back as the 1980s. Some involved giving the peptide through a vein to people with insomnia. The results were limited by small study sizes and weak study designs. Research involving narcolepsy or opioid withdrawal has also been incomplete. The FDA advisory group did not support expanded access to emideltide. This is a useful reminder that a product can be discussed for decades without becoming proven treatment. Semax can be given by injection or nasal spray. It has been studied for migraine, trigeminal neuralgia, and reduced blood flow to the brain. Trigeminal neuralgia causes severe facial pain. Reduced blood flow to the brain is called cerebral ischemia. Online claims go much further. Semax is promoted for ADHD, anxiety, Parkinson's disease, ALS, memory, and brain performance. It is also said to support neuroplasticity, which is the brain's ability to change and form new connections. Semax is used as a medicine in Russia. Much of the research has been published in Russian or presented without full access to all the study data. When someone says there are studies, ask what kind of studies, how many people participated, was there a placebo, were the researchers blinded, were the findings repeated, was the full information published? The word study does not automatically mean strong evidence. The Barbie peptide melanotan 2, also known as MT2, is often called the Barbie peptide. It stimulates pigment production and may darken the skin. Some people use it to tan without spending time in the sun or using a tanning bed. The nickname sounds playful, the risks are not. Melanotan 2 has raised concerns about melanoma, an aggressive skin cancer. It has also been linked with brain swelling, problems involving the nervous system, and priapism. Priapism is a painful erection that lasts too long. It can cause permanent injury and requires emergency treatment. Because melanotan 2 stimulates pigment cells, there is concern that it may also affect cells connected to melanoma. This is one peptide I would strongly advise people to avoid. A cute nickname does not make a dangerous product safer. The Wolverine peptide. The Wolverine peptide is usually not one peptide. It is a stack of TB500 and BPC157. The name comes from the fictional character Wolverine, who heals rapidly. The stack is promoted for muscle, tendon, and ligament injuries, scar reduction, and tissue repair. The name creates a powerful picture. The evidence does not match the picture. TB500 is promoted for healing, inflammation, and athletic recovery. It was first developed as a performance-enhancing substance in horse and greyhound racing. Human evidence is extremely limited. An FDA review found no good human studies and identified only one mouse study. A substance developed for racing animals should not be treated as a proven human recovery therapy. BPC157, sometimes called body protection compound or BPEXin, has been studied for knee pain, bladder pain, and ulcerative colitis. A few studies suggested possible benefit, but they had serious weaknesses. Some had no placebo group, another had not been peer-reviewed. Animal studies have also raised concerns about liver function and blood clotting. There is no clear evidence that combining BPC157 with TB500 produces better healing. The superhero name may be memorable, the science remains uncertain. The main issue is safety. Now we come to the most important part. If a peptide is unapproved or poorly regulated, you must know what you are putting into your body. Is the vial sterile? Does it contain what the label says? Is the strength accurate? Was it stored properly? Was it mixed correctly? What is the correct dose? How long does it remain in the body? Could it affect the liver, kidneys, Heart, blood pressure, or blood clotting? Could it interact with another medicine? Could it increase cancer risk? What happens after repeated use? For many online peptides, we do not have reliable answers. Some buyers are expected to mix powders, calculate doses, and perform injections using instructions from social media. That is not medical care. Most people are not trained pharmacists. A small mistake in concentration can produce a large dosing error. Some users may inject several times the amount naturally found in the body. Others may combine products without knowing how those substances interact. What will you do? Before using a peptide, ask whether it has been tested in people, whether it is approved for the intended purpose, and whether a safer treatment already exists. Do not inject a product labeled research use only or not for human use. Do not let a seller, influencer, or chat group become your pharmacist. Closing peptides are real and important. Your body uses them every day. Some peptide medicines have transformed healthcare. Insulin saves lives. GLP-1 medicines have changed how we treat diabetes and obesity. Other peptides may eventually help with healing, sleep, skin disease, brain conditions, and metabolism, but possibility must be tested before it becomes treatment. The bottom line is this: a peptide may be natural and still be harmful. It may be made in a laboratory and still be useful. It may be prescribed by a clinician and still not be FDA approved. It may work in a mouse and fail in a human being. It may be popular online and still have poor evidence. Before considering any peptide, ask 5 questions. What exactly is it? What is it supposed to treat? Has it been properly studied in people? Who made it and can I trust the product? What are the known and unknown risks? Here is what I want you to remember. Stay curious, but do not become careless. Listen to new ideas, but ask for evidence. Respect medical progress, but never allow excitement to move faster than safety. Thank you.